The Athletic.
The F1 season is back, and once again, Red Bull looks like it's on top. Coming up, we find out what role simulation played in creating the radical RB20 that shocked rivals in testing. Plus, Gary answers your questions on bottoming out, suspension, and downshifts. We're back. It's the new series of the Race F1 Tech Show, and with the new season about to start, it's the perfect time to get the tech juices flowing with chat and interviews every other week. I'm your host, Edd Straw, and once again, there me to bestow his wisdom, built up over half a century in and around F1, since first getting involved with Brabham way back in 1973. So, welcome back, Gary. It's not been long since we were patrolling the paddock in Bahrain, enjoying pre-season testing. Hopefully that's got you excited about the new campaign.
Yes, and I think we're all pretty excited about the race season starting because, no matter how much testing you see, how many lap times you see, how much you look at the cars out on the track, you never really know what the test program for each team is. It's going to be Friday, as in Bahrain, for qualifying, before we really know what the performance level is of each of the teams, because that's the first time they'll really have new tyres on, low fuel, driver commitment and team backup to go and do the best job possible. And then again on the Saturday afternoons, as in Bahrain, it'll all be about the tyre degradation and how good the car is over the stint laps. So it's one of those things. This is the putting the light switch on to see where everybody is, and then the teams have to react to that and get on with it and try to fix the problems. So yeah, I'm excited about it. I'll be up watching it and analysing it and doing whatever I can and reporting it in the race.
Exactly, and the first race of the season is always exciting, so you never really know what's going to happen despite the indicators of testing. Now, we'll get on to our main topic, which is CFD simulation with Ansys, shortly. But as always, we'll start off with an open floor for a topic of your choosing. So what's on your mind, Gary, after F1 testing?
Yes, again, all this simulation, CFD, etc. Just know any simulation that you do on the car now has taken over from a lot of practice. But it's one of those sort of things. The first race of the season, it used to be you got to get to the checkered flag because that's where you get the points. And the first few races of the season was where people would have some reliability problems in one way or another. But these cars are so reliable nowadays. I wouldn't be surprised to see this new season starting with, 20 cars and all of them finish, because it's just one of those sort of things that everything gets better year on year. So you just end up understanding all of the stuff about the cars. I mean, even if you go back to 2013, I think it was Jerez they were testing, and Mercedes had a front wing failure, and it's one of those things where now those. That doesn't really happen unless it's some sort of manufacturing fault, because they have so many rigs to test all this stuff. All the suspensions goes through proof testing, load testing of some sort or another before it ever meets the car. I know back in our days, we didn't have the money with Jordan to have all these test rigs. So loading up the front wing and the rear wing, for example, which is very critical parts of the car, we used to take the wind tunnel data, try and separate the loads that were in the front wing and the loads that were in the rear wing, and then we go down our local builder's yard and buy bags of sand, and we'd load the wing up to suit. It worked quite well because the load distribution was there, and so you could pile it up just to hear some creaks coming, and then if you're measuring the deflection, you can see if it's linear or if something has moved quickly, and react to it. But nowadays, it's the cars go in the rig and everything is so precise, to be honest, before it gets signed off for use at the track. So it has done a lot of good things for Formula One, but it's also made the cars, nigh on 100% reliable, which is never the best thing, I suppose.
What's remarkable is that there's been this debate recently. Fernando Alonso kicked it off about there not being enough pre-season testing, which he looked at from a driver perspective, just a day and a half in the car each. But really, the fact is 3 days of testing pretty much is now enough for teams. Obviously, there's always more things they can do. But as you've alluded to, with all the things they can do with simulation tools and that kind of thing, testing really goes on throughout the winter, doesn't it? And ever since the testing ban in 2009, when we had the in-season testing ban first in, the effort that's gone into all of that means that it's all so rigorous. It's not just that the build quality is so much better and the load studies and all those kind of things, the science that goes into it is better. They can also literally just test things so much before the car actually hits the track, and everything is tested in the real world. Obviously, simulations are always only simulations. They all have limitations and areas where things are simplified. But day one isn't really day one of running, is it?
Yeah, there are drivers. I mean, Alonso was complaining about the amount of testing that can be done. It's never right or wrong because, as I say, it's not just what we see at the track. There's a lot of work goes on back at base. Renault have said they've had their car on a test rig and done thousands of kilometres worth full size car, but it is never quite the same because the tyre vibration you get from the slip of the tyre, it doesn't just grip constantly; it vibrates. The vibration from the curbs, the lateral forces and longitudinal forces that you can't really represent on a rig are all added to the loads that you put into it. But it is the track that matters because that's what the car reacts to, and the driver reacts to that feeling. I think there isn't enough testing quite. There is enough for the experienced drivers, but I think there should be an extra. Let's say if you move teams like Lewis Hamilton to Ferrari next year. I know he's a very experienced driver, but still I think that's worthy of an extra day for him to get his feet under the table with the team. And I think if you're a team that's trying to find that new driver, like, again, Mercedes are for next year, that new driver that they do sign up, be it that he hasn't done any worthwhile Grand Prix, let's say 2 Grand Prix, he should then get a couple of days extra just to get his feet under the table as well. Because these cars are so complicated. It's not like you jump straight in from a Formula 2 or a Formula 3 car, and as Max Verstappen did, as Kimi Räikkönen did, those people, these cars are so complicated to drive and drive properly that you need a little bit of time in them. Yes, you can practice in the simulator, you can do all that sort of stuff, but there's nothing like getting the feeling correct of what the teams, really do. It's one of these sort of situations where, more time doesn't do any harm.
Yeah, and that's always important to remember, isn't it? It's not just about the teams needing to test. There is benefit for the driver, and particularly new drivers here. I'd entirely agree with that. Let's get on to our main topic now, and it's a timely one, given Red Bull is once again favourite heading into the new season, because we're talking simulation technology with Ansys. Before we get onto your excellent interviews, Gary, how big a part do you believe these technologies play in Red Bull's supremacy? As is mentioned in one of your interviews, part of the reason Red Bull was willing to be so aggressive with the look of its 2024 car was the ability to prove it would work to a high level of confidence using such tools.
Well, yeah, CFD has become a massive thing now. Any simulations become a massive thing, and Ansys obviously do, a very good product, and Red Bull do a very good usage of it, I suppose is the best way of putting it. It's never one-sided. It's never just getting this mega tool and it works for you. It's all about trying to make sure that you have a working relationship with any engineering company that you're working with. And Ansys is one of those. As I say, it's a two-way thing. Red Bull will report back about what they think is the shortcomings of the software that they're using, and Ansys will find solutions to them using it differently. So it's a spiral to success, and it allows Red Bull to try out some different solutions. And I think, as a good example, their cooling solution for 2024, even for 2023, their cooling solutions were different, and that's allowed them to do that because of their relationship with Ansys and the fact that CFD is so powerful when it comes to designing a ductwork. A closed duct is much easier with CFD than in a wind tunnel, and it's much more accurate because you can check for all the airflow separation problems just down in little corners where the radiator is, because you could suddenly have a radiator with a surface area of X, and a tenth of that radiator isn't actually getting any airflow. So CFD allows you to do that, and mainly because it's a closed duct, it's a contained pressure change within that duct and velocity change of the flow. Again, it's good for brake ducts, although they've got so complicated now. It's the modelling of that is a nightmare. But we first got introduced at Jordan to CFD back in 1997, and we modelled up an area around where the contact patch, the rear tyre rolls onto the surface, that contact patch where the floor is, which was very critical. And we modelled up a couple of pieces that one was better than our normal solution, we felt, and one was worse than our normal solution. And we tested them both at the track. They were just small pieces. And it was, it was a positive for the better one. And even Simtech, before they disappeared out of Formula One, they tried to put together a complete car using CFD. It was a bit too early for it. It didn't really function best for them. But again, the team wasn't a strong team. So perhaps a team like Red Bull doing it then would be okay. But I think we're at the minute now, it's like a 50-50. If we went to all the teams and said, right, okay, we're going to ban either CFD or wind tunnels, which would you rather we would ban? I think some of the bigger teams would say the wind tunnel because they have evidence that CFD is going to take them forward further. And some of the smaller teams would say CFD because they're not strong enough, manpower enough, big enough, whatever you like to call it, to actually make best use of it. So it's just right on that seesaw at the moment as to which is the best.
Well, we're going to learn plenty more about it now with these two great interviews you've done. The first is with Dr. Christophe Bianchi, Chief Technologist at Ansys. He's been a key player at Ansys since 2019 and has an illustrious 35-year career combining technical and business expertise, and tells us about what part the company plays for Red Bull.
Just a little bit of background, really. When did Ansys get involved with Oracle Red Bull Racing? Have you been there involved a long time?
So yes, it's if I recall right, we've been working together for the past 15 years now. So it's really a long story of bringing simulation as a tool to address the challenges that Red Bull had in Formula One.
Yeah. Was it something you had to develop a special platform for? Because obviously motor racing is a little bit different from an airplane flying at
There's definitely some adjustment to what we had to do. We learned a lot from this collaboration. It goes two ways. Of course, external aerodynamics has always been a field where we've been working heavily with airplane manufacturers, regular car manufacturers for reducing the drag. But the specifics of Formula One racing are pushing the tools to the limit. And so we had to improve and work jointly with the Red Bull Racing team to improve our offering over the years.
And obviously the regulations changed for 2022 into more ground effect cars. Has that again sort of made you scratch your head a little bit as to how you can get more information out of ground effect cars?
Yeah, so there are two things. We've always been modeling, of course, ground effect, but now we have to consider a more defined and precise model of the entire car, not just the front wing. And it's also the combination of physics that is interesting. It's not just aerodynamics, thermal and heat dissipation is a big element also of the calculation. So it's this combined physics that make it a interesting engineering problem for us to solve.
You've sort of answered this question really, but obviously we hear a lot about business on business or B on B as you talk about. Is that how you look at this relationship, that you can develop your product as you develop Red Bull's product?
Yes, we are scientists. We're simulation specialists. We're not car specialists. So we have to work with the most advanced players and engineers in each field to push the limit of our tools. What we've learned from Red Bull, especially the constraints with a new regulation imposing budget constraints and limitation, also pushed us in improving the performance of our software, so we could do more in less time, or more variation, more trials. The fact that Red Bull Racing or RBR has completely revamped its the structure and the shape of its car means that we had to do way more simulation at the faster speed.
So, how can CFD and Ansys sort of bolster versatility as it relates to that change of direction? Because obviously Red Bull's car for this year has, as you say, it has some thermal characteristics that it's managed very well, plus the fact that it is still a car that produces downforce to go faster.
Yes, and to add to the complexity, we also have to take into account that the configuration of the car is not the same for every race. So we have to be in the capacity to produce enough information for the designers to make and the engineers to make the right trade-off before and during the race. And that's where what we call digital twin is the effect that we are measuring a lot of parameters during the race, but we'll still run that on simulation models back at quarter to be able to tune and adjust the parameter from lap to lap or race to race.
So you're involved with actually sort of developing the car as it's going around the track as such?
Well, I wouldn't say we as engineers, but our technology definitely is. What we do as engineering company is we provide the right tools and we listen to the requirements and the demand. Sometimes the demand are actually quite precise. We scratch our head a little bit and we do our best to comply to the demand, and sometimes try to anticipate the demand. What's interesting in simulation is we're in the complete virtual world. There's a lot we can do about trying out various parameters, various configurations, various designs without having to go to the costly effect of building a prototype and putting it into a wind tunnel, which is costly, plus with the limitation of the amount of time of wind tunnel, it's the only alternative.
For 2024, I think we've seen that most other F1 teams are, let's say, following Red Bull's lead in their car visual concept, I suppose you might call it. You must feel quite happy that your simulation system, CFD simulation system, has led Formula One in that direction, because you're not only actually sort of benefiting from one team now, you're benefiting from 10 teams.
Well, I don't want to steal what really belongs to Red Bull Racing engineers. They design the front wing. What we did is provide the tool to help make the right trade-offs and the right choice in design for the best performance, safety, and of the car. The fact that these results are being replicated by other brands this year shows that you won most of the race last year, so that's probably one of the reasons they're trying to copy.
Yeah, it's one of the reasons, but also it's obviously something that copying means that you're one step behind your competitors. You're never quite going to lead the path, you're always following the path, so you must get a lot of potential from other teams wanting to use your product as well. So we again what we provide is a hammer in the tool shed, and what we simulation, CFD simulation, is no magic. It's just a way to represent the physics in the virtual world as closely as possible to reality. The fact that we learn a lot and we improve our tools so it's really very accurate and very close to what's happening on the track is definitely making it a reference for other car manufacturers, and definitely trying to replicate the same design. One of my first involvements with CFD was back in, I think it was 1997, somewhere around then, and we modelled up some of the flow around the rear tyre and the corner of the floor where it meets where the tyre rotates onto the ground. And we made two samples, one that we felt was better than our current car and one that we felt was worse than our current car. Small parts, and we went and tested them, and it correlated very well, so I was very impressed. But I never really got the chance to spend the money that needed to make it into something that we could design a car with. Do you see CFD being able to do away with the wind tunnel?
So wind tunnel was always detect things that we cannot simulate, in the sense that simulation is only giving an answer to the information it is given. So there are parameters that if you don't define these in the CAD model you're using for simulation, it's not going to give you the exact answer. But we've seen in the many years of collaboration with Red Bull Racing that we could come very close to the wind tunnel results, to the 90 plus, 95 plus %, which means that we can run many more experiments before committing to a prototype. Because with a cost constraint and a budget constraint on a race, you can only build one prototype, so you can only adjust it. Some early design choices, design trade-offs are better made in simulation. And in simulation, you can simulate a lot of different conditions, weather condition, type of tracks, or even specific demand of each driver.
Yeah, and you just mentioned there the ever-tightening sort of cost caps that Formula One teams are constrained with now. I mean, I remember when people were spending probably 2 and maybe even 3 times the money they spend nowadays. So that must be a very important part of what you can offer through Ansys to Red Bull Racing, the fact they can do more for and stay within the budget cap.
Yeah, and it's also a reason why the ORBR team is pushing really hard on us to do more simulation in less time, because time on computers is a cost. And so to reduce the cost of simulation, we've been asked to go much faster. So it's probably with the demand and push from Red Bull Racing that we moved all our software onto GPUs, because they provide much faster results, much better results in less time. So we can do more under a constrained budget.
Yeah. Obviously, as you said earlier, it was a fairly successful season, 2023, for Oracle Red Bull Racing and yourselves, obviously Ansys. What do you think you'll see from 2024? Are you expecting the same domination from the team, or are you a racing enthusiast, or do you just want your product to do well?
No. So we know our product are helping, but in the end, it's the drivers behind the wheel, not the software. So, and I think there's, as you said, competition has been trying to look and copy what Red Bull Racing has put. So there's a lot more innovation in the new car this year. I'm so eager to watch the race. I'll be flying back from Barcelona, and I'll sit in front of my telly until the race ends. I'm really a fan and enthusiast for F1 racing.
Yeah, I'm looking forward to it as well, because it's the first time we will know where everybody stands. I mean, all this testing is great stuff, but it doesn't, till qualifying runs, you don't know anything really, to be honest.
That's true. Yeah, and for us, it's also it's the start of the season, so we know the car is going to evolve, and it's going to be more and more simulation required, and more of our support required throughout the year to fine tune and adjust and improve the car over and over. We all know that the car at the last race is not the same as the one in the first race.
Yes, and sort of looking forward, really, the regulations are changing again quite dramatically for 2026, and the teams aren't allowed to start to research their aerodynamic profiles until January the 2nd, 2025. So that obviously means that the speed of your tools is very important. And how do you see development during that period? Do you think you'll increase the speed of your product?
There are many things we're doing. Of course, we continue to try to improve the performance of our tools. But on top of that, we're also adding new capabilities, new technologies such as machine learning and artificial intelligence in our software, so we can quickly explore more variation, leverage and reuse some previous data, even if they're not for the same characteristic, to provide more insights and more data for the designers and engineers in a smaller amount of time.
Yeah, the focus on the regulations, or part of the focus, is on sustainability and efficiency. Red Bull have to try to meet those requirements. Do you think you can help them in that front?
We've already started. We started working with Red Bull Racing on what we call material intelligence. It is, in addition to simulation, it's modeling all the characteristics of all the material used in the car, but not just to be able to pick and choose the best trade-off of mechanical sturdiness and flexibility, but it's also the complete life cycle of the product that is embedded in its material database and material information through its design, use, reuse, and recycle. And that is really a key element. We can help select the right parameters and the right products in the car.
And does that help, you think, with the outside world? Does the knowledge from that improvement in materials or understanding of materials move into aeroplane technology or road car technology?
it is demand that is coming to us across all industries. We see that from the packaging of pharmaceutical components in the healthcare industry. We see that in oil and gas industry. We even see that in military and aerospace, where they want to have a sustainable warfare systems, which is an interesting concept. Kind of an oxymoron, but this is what we see in all industries. And once again, Formula One is ahead of the curve in all of these dimensions, and all the work we done with RBR is helping us with all the other clients in all of the other industries.
Well, there's a lot of people, I hope, listening to this that probably won't want as dominant a season as was last year for Oracle Red Bull Racing and yourselves, but you're one of those sort of things that's going to start pretty soon, and we'll find out who's done what. So thank you very much for your time, Christophe. It's been great to talk to you, and you have a great product there, and well done.
Thanks, Gary. Finger crossed.
Well, great stuff there from Dr. Christophe Bianchi. That's not all we've got, because Gary has also spoken to Red Bull Technical Director Pierre Wache, one of the masterminds behind the most talked about F1 car of 2024, the Red Bull RB20.
Pierre, thank you very much for your time. I'm sure you have other more important things to do, but it'd be nice to talk to you about aerodynamics. We all know these racing cars are an aerodynamic projectile, a bit like an aeroplane, but upside down. And you've only really got two tools, a wind tunnel and CFD simulation to optimize it. How do you go about balancing the use of the CFD and against the wind tunnel?
I think the first part of the development of concept is coming from CFD. Is mainly due to the practicality of it, first of all, because you can design and mesh the system and going directly to results with a certain time of computation. And the wind tunnel still need some physical part to be made. That is the same system as more or less the real car. You don't see the same thing in both tools. You know, you clearly see with the CFD some quick potential development and understanding and massive measurement of the flow. And in the tunnel, you don't have this type of capacity to see everything that you can see in CFD.
These regulations came into play in 2022, but Oracle Red Bull Racing has had a lot of success over the years anyway. But these regulations, obviously, it's ground effect cars now, so the downforce is produced near to the ground. When they did come in, a lot of people suffered from porpoising, and the complaint was they didn't understand that from the tools they had. How did Red Bull handle it? Because your car was very good, really, from the beginning.
We first of all clearly that the concept of the car we develop in the different tool we have, like the main two tool we have, and the target we have was to develop at a certain level of ride height and a certain level of speed corner development that we think that still low speed is a main lap time sensitive area that we have. Then we push quite a lot in this area by maybe dismissing a little bit the high speed aspect. That fortunately we had maybe less or similar level of bouncing than others. However, we had a bouncing at this level of at the first test, maybe unexpected bouncing. The quality of the team and the quality of the tool we have gave us the opportunity to react quickly to that. And I think it's a chain of development between tool of aero that you develop and how it integrates in the full system for aero part development, but also vehicle dynamic. Because it affects the dynamic of the car, as you can imagine.
Yeah. So the obviously we see the development of the car, but behind the scenes you must be developing your CFD programming and understanding and trying to get it more correlation with the track.
Yeah, I think we have I would say, not to make a secret, but you have to constantly develop your CFD tool and your CFD setting. And the people at the factory, we have experts doing that, try to make correlation between CFD and wind tunnel and CFD and track to make sure that you have a good representation of a system, but also in the different operation you are using the system, because the operation you are using will also affect the result of it. It could be boundary layer and all the aspect and you change in your setting. That for sure, the CFD particularly, because we can tune it, is in constant evolvement to be closer as possible to what you can see.
I think this year, for the start of 2024, you surprised everybody by theoretically changing direction with your car development a little bit. But you must also you must have confidence in that because of your CFD simulation and other simulation tools that you have, that you've gone in the right direction.
Yes, it's true. If we were lost in the previous 2 years, we will not take this risk this year to develop this type of car. And when, for sure, we have issue like everybody, but our capacity of our current tool to give us the right direction, seen in the last 2 years, give us the confidence to do for this one, and confirm again that we were not completely stupid to do that. I confirm again, I stop to say that we are quick. It is the correlation we have is not as bad as we can have in the past, to be honest. And it gives us the possibility then to take a little bit more risk or to take some different avenue to achieve a certain philosophy by having this type of correlation.
You must feel fairly proud whenever you look down the pit lane at the other 9 teams from 2023 to 2024. They've obviously followed your aerodynamic philosophy to a high degree. Does that make you feel like, okay, we got that right, now they're all chasing us?
Yeah, I don't know if I'm proud. I'm proud only when I'm not losing.
Yeah.
if it's the main aspect is I think as others, we have also some item on our car that it could be coming from somebody else. I think the paternity of an ID is not defining the performance of it, and I know from fact that some other could be very good to extract more performance than sometimes us. Then is nice to see, but is not the main purpose. The main purpose is to be able to see what the others are doing, try to extract the most, and put it in our system and understanding what they are doing. Is the main thing for me.
And your new car, as I say, for 2024 is quite a different package. Do you see that as keeping that step ahead of the other teams? Because obviously, as I say, the other teams are more like your 2023 car.
I hope, where we were standing, I think the philosophy of the car is similar in the term of what we try to achieve. Is more the solution to achieve it is a little bit different. And we see that the main purpose of going to a different solution and taking some risk is clearly, as you mentioned, to try to gain a performance aspect that we were a little bit struggling with the previous concept of the car. Doesn't mean the other will not find more. That either we are in constant battle. Mm-hmm. But yeah, I hope so. I hope it will be, we will have a massive advantage, but I know that the other team are also developing some very interesting idea.
Yeah, and as far as the rest of the car is concerned, obviously there's quite a few crash tests, impact tests, etc. And CFD itself modelling only gives you the body surfaces. How do you model a lot of those other impact tests before you actually go and carry out the physical tests?
I think the simulation is in every area of our business, to be honest, especially in CFD or finite element, FE, is big part of our business. First of all, to make a quick understanding and to be able to see multiple solutions quickly to define what we want, but also now even more with the budget cap aspect. You have to be able to have a simulation that you trust, to be able to develop fundamentally your car, because you cannot afford to create a physical part and destroy it. Mm-hmm. It could be on the crash test, like a finite element, or on CFD, the same, to create a part and say, just to see the direction, if it's not a good one. That clearly, all these simulation tools are fundamental to our development.
So the for 2026, the regulations are changing quite dramatically, I suppose you might say. And you're limited, you can't really start the aerodynamic research until January 2025. So it only gives you a year to research that car. Does that mean you'll use these CFD tools more? Or does it mean you'll just have to sort of like plan a development program, or you sort of, is it a balance of both?
I think it's clear that it will depend a lot about our current performance and where we are on the track, but it's clear that CFD will be used even more on the new concept of the car. And I will say the same for FE, but we will be able to start this CFD research 2nd of Jan, because it's bank holiday first, but 2nd of Jan 25, and it's clearly all the main work at the beginning will start with a CFD and to define what direction of the concept will be.
In the past, let's say 15 years ago, you could basically go testing every day of the week if you wanted to, and now that's been restricted. So it's become more about simulation tools. Which would you rather have? Would you rather have a balance of both, or would you rather have more simulation tools and less testing, or more testing and less simulation tools, if you had to make a choice?
If I make a choice, I will say I will like to have a less restriction on simulation tool and be able to test to verify my simulation tool is working with more money.
Yeah. So that's sort of the best of both worlds, isn't it?
No, yeah, it's for sure, because we are not racing the simulation tool. Mm-hmm. We have to still to do a physical part, and the constant improvement on simulation tool give us the confidence to develop. I don't dismiss that, but if we want to do another step, it's the same in every world. You still need correlation exercise and see multiple direction, and for that you need some test.
And during a race weekend, obviously you have the practice sessions, which are now becoming a little bit more limited. How do you work with the base? Do you send all the data back and they do simulations back at the factory overnight between Friday and Saturday, or?
Oh yeah, it's clear that we have all the simulation going back to the factory, especially during the session and after the session, based on the issue we have, based on what we try to understand, and especially now on cooling and some critical area that is so much detail requirement to find the last bit of performance we are trying to achieve. On top of that, when you have issue like some track that is very, very demanding, like Mexico, or when it's one off track, you need to develop a certain aspect of the car that the feedback from the track will be required to finalize the last bit that we put on the car to cool the car or to overperform.
Mm-hmm. So your analytical team back at the factory would offer suggestions of setup and cooling arrangements for the next day?
Yes, correct. The team at the factory has a expertise, where the expertise is in terms of overall each area, will advise the track to different direction or confirm the direction of the track, and the track people will try to combine this type of thing to extract the most of the performance. Yes.
Mm-hmm. And as just a rough number, how would you say your correlation is with the track from the simulation tools? Would it, is it 90%, 95, 98, 100?
It's not 100. I would say it's between 90. If we say a lap time is 100 seconds,
yeah.
We are between 99 and 100.
Okay, that's very, very good then. So you've got confidence in that, so that
but it's good in our sense. However, you lose 3/10. It's between
6 places on the grid.
Correct.
So, but you still got confidence that the simulation tools you're using back at base has got a good grasp on how the car will respond. Even the tire modelling, is that a problem, or is that good?
We still have a room of improvement everywhere. I think the tire modeling, I'm even maybe more personally involved about it. That I will not say that is good. I think we still have to improve. But yeah, we try to be around this kind of 1% delta between the stuff. And if we don't understand something, in the modelization, you cannot model everything. After you have to say, in the modelization has to be used as an engineering tool to understand the sensitivity of each area, each component. And sometimes I don't think is interesting for the system to have a fit more than the physical model. The physical model is more important to understand the direction you are going, is why we are trying to push for.
Okay. And your two drivers, I mean, obviously drivers want different things. Does that mean you have to sort of simulate things in different directions a little bit to suit their needs?
Yes, it's part of a combination of work with them in the simulator, and to define what they need, and based on what they find on track, the requirement at the factory during the session or after the session to advise the direction of setup will depend of what their feedback previously was, and give the direction for that. Yes.
So Pierre, you use Ansys Fluent as your CFD tool. Do you think it's a high level of simulation?
Yes, it's clearly this type of CFD tool, especially Fluent, is a massive advantage to develop the car. You need this TFD tool to be able to make the concept of the car, to be able before to put in the wind tunnel to materialize what the direction you are going, and to make it quick decision on the direction you will want to pursue.
And do you think that will ever really take over from the wind tunnel? Obviously, it's getting more and more relative as time goes by, but it's a very important part initially. But will it ever take over from wind tunnels?
At the moment, with the FIA, with the FIA restriction we have, is difficult because we don't have enough computing power to achieve the full wind tunnel stuff. But with currently what especially Fluent, what it gives us the possibility to use is they are currently using GPU to what they use for artificial intelligence. Sorry, I was trying to put in French. Sorry. They use a GPU to compute that we are not allowed yet. Give us a massive power to develop some full transient simulation, and we are not allowed yet to use this kind of capacity.
So with CFD, the future's bright.
Yeah, it's correct.
As always on the Race F1 Tech Show, we like to get the readers involved. In fact, Gary's a huge fan of answering questions and never seems to tire of being illuminating, so the question section of this podcast is always a favourite. If you want to know how something works in F1, please send us a question and we'll do our best to answer it on a future episode. You can either write us a question and email it to podcasts@therace.com, or record a voice note remembering to include your name that we'll play in the show. And as I always say, there's no such thing as a stupid question, so if you're wavering, do take the plunge, because you will get a good answer out of it, and it will be far more complicated than you might think. So the first question for you, Gary, is from David Shankel, who says, my question is about the sparks and smoke from underneath the cars on track during the test. I assume the sparks are from the carbon fibre hitting the ground, primarily the T-tray. On the run to turn 1, just before the 150-metre board, most, if not all cars hit the big bump and a puff of smoke ensued. Why is this impact with the track inducing sparks most places but smoke here? Is it the plank? And if so, might compliance be an issue in scrutineering?
Well, David, there's never smoke without fire, I suppose is the best way of putting it. When the plank first got introduced, it was basically a plank. It isn't just a wooden plank. It's a high-density, compressed, resin-filled wood. And it's got about the same sort of hardness as aluminium, I suppose you might call it. But what will happen is it will wear underneath the car if you do let it run on the ground all the time. Now, we've seen people getting banned, both in its early days with Michael Schumacher at Spa and in Austin in 2023 with Charles Leclerc and Lewis Hamilton. But now there is a lot of skids underneath the car. Skids all started because, the plank wasn't practical to put bolts into. and the wear was becoming something that was becoming a major attention by the FIA. So they allowed you to put some 50 millimeter roughly skids underneath the car. At some point in time, I think it was 10 you were allowed, and you could position them where you wanted. So in other words, you could position them where the wear was more critical to you. But then people started using tungsten underneath the car to lower the centre of gravity, because the weight of the tungsten is like 20 times the weight of water, so it's pretty heavy stuff, even though it's small. But they were then falling off, and it wasn't a good idea for them going into the marshals or into the grandstand, because they were so heavy and so small you didn't see them coming. And then, so that all changed to being, you had to use a lighter material. And then whenever night races came about, the FIA decided that it would be nice to see some sparks, or Formula One decided it would be nice to see some sparks underneath the cars. So you had to use something that would spark, i.e. titanium. So the density of it was reduced, and the sparking was increased, I suppose. And it does look good. But now there is one large skid at the front of the car, because the front of the car is the one you run close to the ground majority of time. And then there's about 6 other smaller 50 mil diameter skids placed around the car. Everybody has to have them in the same position as such. And it's the area beside those skids that will be checked for plank wear. So in other words, whenever you hear that the plank's worn out, it's not just the plank that's worn out, it's the skid that's worn out as well. So it is interesting because, you know, the front skid we can see when a driver arrives at the corner, especially a long straight with the DRS open. We can see the front skid sparking merrily. And then when you shut the DRS, it suddenly stops because you move the centre of pressure of the aerodynamics further rearward. And, you know, it reduces that wear. And on the front of the car as well, there is a spring and damper unit on the front, the tongue of the floor, to allow the car to hit the ground hard and not actually damage the chassis. That's a good idea. There is a load test for it to make sure it doesn't compress too early, but it does stop the chassis getting damaged going over a curb. So I think whenever you see the smoke on that bump, turn 1 in Bahrain, it's about just the fact that the bump is enough for the skid to hit it, and then the plank to also ride down it. But it's there for such a small amount of time that the skid will have done the work, and the plank itself won't really be suffering too big a wear rate. But it is something the teams have to keep good control over, because, you know, it can get out of control. So you'll see a mechanic underneath the car nearly every time the car comes into the pits, and he'll be measuring the same position as the FIA would check it. He'll be measuring it with a little depth gauge. And obviously if it's too low and wearing too quickly, the engineers will create a sort of spreadsheet on it for the amount of laps run, the amount of fast laps run really, and predict the wear rate over the race distance. So you've got to keep an eye on it. You can get done for it. If you do get done for it, it will be, you know, after the race because of all the laps you've just done. So it's something that's definitely gets your attention.
Yeah, and always worth experimenting during testing on that as well. The next question is from Johan from Stockholm in Sweden. You often mention that downforce increases with the square of airspeed, and that the downforce needs to be controlled to avoid the cars that are sucked into the ground starting to porpoise. What are the tools used to control the downforce increase with speed? Can the wings be designed to increase downforce less at higher speed? Is the floor designed so that some parts get staffed for air and stall when the floor gets closer to the ground? Could this be used to control the centre of pressure? And does a rising rate suspension / bump rubber simply stop the car from coming closer to the ground?
Yeah, Johan, it's just an aerodynamic principle, the downforce increasing with the square of the speed. It's one of these sort of things where it does, you know, suck the car into the ground as such. The wings push the car down, the underfloor sucks the car into the ground, and if it gets too close, then you can instigate porpoising. The porpoising is when some part of the aerodynamic system, either wings or underfloor, the airflow separates on it. And the one thing you want to make sure is that the stall means that the downforce still increases. You don't want the downforce to decrease, because that's when you get porpoising. In other words, if you had 2,000 kilograms of downforce at 200 kilometers, and then you had 1,900 kilograms of downforce at 210 kilometers, the car would rise up in the air again, and then that stall would reattach and it would suck the car back down again. So the car would start what's called porpoising. We've seen this in the past with front wings when they were near the ground. You know, you get the front wing stalling, and the stall would be more than the stall would go to a reduced level of downforce, and the front of the car would start bouncing. So porpoising is all about not allowing the downforce stall to decrease the downforce. It just has to increase it less, and then the car will stay stable. Nowadays, the wings are probably responsible for 30-35% of the overall downforce, and the underneath of the car, 65-70% of the downforce. Not quite 100% sure what those numbers are now because the underfloor has been getting more and more powerful. But the thing about the underfloor is that you can sort of play games with it in the fact of where you have the airflow separation underneath it. If you separate the flow early in the floor throat, in other words, the lowest part of the floor, then you will get the centre of pressure moving rearwards. I suppose it doesn't really have to be the separation is in the earlier part of the floor. It just means that the separation has to affect the earlier part of the floor. So what you want with these cars is, if possible, the downforce to move rearwards the faster you go. And as I say, it still needs to move rearwards even if you have some separation problems. So it's all about managing the airflow structure. And then on top of that, you have the suspension. You got the anti-dive in the front to keep the front from diving into the ground when you hit the brake pedal. The anti-lift in the rear, again, to stop the rear coming up quickly when you hit the brake pedal. But on the way there, you've got the normal suspension system. When the car's just getting vertical load and it's not getting a longitudinal load, you have a normal suspension system, and that is combined with two side springs as such, torsion bars, and a central spring. And all of that can be adjusted in stiffness and when it comes into play to support the car's loads. And also the fact that rising rate on the front suspension means that the front suspension can increase in how it supports the load the closer the car gets to the ground. So in other words, it increases the stiffness of the front of the car as the car gets nearer to the ground. So it means you've got a softer suspended car in lower speed corners and a stiffer suspended car in high speed corners, which is ideally what you want. So it's a combination of everything, but you can't forget the tyre. The tyre is a big black rubber spring, I suppose you might call it. And you can't change the damping in it. You can't change its rate other than by increasing the tyre pressure. If you increase the tyre pressure, you just lose grip in general. So there is an optimum, and we see nearly all the drivers want the tyre pressure to be less than Pirelli define as their minimum. So that's why they end up going out of the pits so slowly, to try and let the tyre pressures come down, because you get more grip and you live with the porpoising that the tyre generates. So it's all a combination of everything, and I think Johan's the best way to put it. And nothing gets left whenever you're analysing what you do to A, increase the downforce in the car, and B, not have the porpoising. So yeah, it's a big task.
The next question is from Mike Listmeyer from Pennsylvania, USA, who says, I watch quite a lot of onboards and each driver has their own style of downshift. I was watching Lando Norris the other day and his is different than most in that he starts his downshift, say, from 8th to 7th after a long straight before he's braking, and it sounds like the revs spike in an unnatural, violent way. I want to know whether or not the way in which drivers downshift can put added stresses on the gearbox, whether that is what Lando does, the swiftness of getting down the gears, etc. It's an interesting observation, isn't it, Gary? Because there are differences in the way the gear shift is executed from driver to driver. So what can you tell us about that?
Yes, Mike, every driver does have their own way of doing things, and there's lots of different ways of wanting your car to turn into the corner, or analysing how you should make your car turn into the corner better. So it's just one of those sort of things where Lando does do it slightly different. Is that right or wrong? Well, it's what he believes is the right thing to do. If you change from, as you say, 8th to 7th after a long straight, in general principle, that's quite a good idea, because the DRS shuts when you hit the brake pedal, and going from 8th to 7th to maybe even 6th, you are for sure in a straight line, and you're probably talking during that period of 2-3 tenths of a second, but you are also talking probably 30-40 meters of track. So it does mean that you are having DRS assistance for further. It doesn't shut until you hit the brake pedal. So if you can change down gears still in a straight line, you'll still have the aerodynamic advantage. You will be decelerating the car to some extent. And it's sort of one of those things where you're using the gearbox to slow the car down, so you're not over braking the car. You're not causing extra brake temperature or brake heat. So it's a combination of all of that stuff to suit some corners. Some drivers like to change down late into the lower gears just to keep the load transfer onto the front tyre. But when you do that, it means that the rear tyre is losing load. So it depends on your car. If the car has some understeer, then you'd want to do that. If the car has a nervous rear end on turn-in, you wouldn't want to do that. So again, it's all about reading the way your car reacts to everything. But the problem is, if you have it as a standard driver mechanism, I suppose you might call it, you can suddenly create the problems. And it means that you sort of are trying to engineer the car around your own self-created problems, and that's never a good place to be. So I think you have to have a fairly decent standard way of driving, and then you adapt the setup to suit that. These days now, it's not really any more stress on the gearboxes. With the semi-automatic shifts, it takes care of all that. It won't do things if you do it at the wrong time. And back in the old days, I remember we had drivers who could break gearboxes no matter what you had, and other drivers that were very good on them. So it's not so much about that nowadays, but it does cause more stress. You just need to be a little bit more careful here and there, but the driver can't do much about that. It would again be the setup of the semi-automatic gear change electronics that would sort of reduce the stress on any problems there. But yeah, every driver will do their own thing. You can't doubt Lando's a quick driver, so what he does is not wrong, but you need to keep your mind open and be adaptable to suit a given situation at any point in time.
And I think it's worth noting in the case of Lando Norris, there's a lot of things he does in the way of driving in the detail that are quite intelligent. He really thinks about this stuff, and that's what actually allows him to produce some very good race stints. Actually, he's a very sharp operator. Well, thanks to David, Johan and Mike for your questions, and thanks to Gary for the answers. We're turning our attention to the Bahrain Grand Prix now, so join us in 2 weeks for more from Gary.
The Athletic.